A long-haul aircraft can carry over 200 tons of fuel. That is more than the empty weight of the aircraft itself. But the fuel does not just sit there. It is constantly moving inside the aircraft, and that movement controls how the aircraft flies. The fuel system is one of the most underestimated systems on a commercial aircraft. Most people think fuel just sits in a tank and gets burned. It does not. I am a licensed aircraft maintenance engineer. Let me show you how a modern fuel system actually works. A commercial aircraft can take on tens of tons of fuel in minutes. It is pressure refueled through a single connection point on the underside of the wing. Fuel is pumped at high pressure directly into the tanks via a network of internal pipes. The refueling panel controls which tanks fill, in what order, and to what quantity. The flight crew specifies the required fuel load based on the route, weight, weather, and reserves. The aircraft is not just filled to the top. Fuel is loaded precisely. Distribution between tanks matters from the moment the first kilogram enters the aircraft. The wing itself is the tank. The fuel is stored in sealed sections of the aircraft structure. On most modern airliners, there are three primary tank locations: the left wing, the right wing, and the center tank in the fuselage above the wing box. Larger aircraft also use trim tanks in the horizontal stabilizer at the tail. These are not separate containers bolted on. They are sealed sections of the structure itself. Each tank is monitored continuously. Capacitance probes measure fuel quantity. Temperature sensors track fuel temperature. Water detection systems monitor for contamination. The data flows into the fuel quantity indicating system, the FQIS, which displays the contents of every tank to the flight crew in real time. The crew never have to guess how much fuel is on board. They know to the kilogram. Fuel does not stay still during a flight. It is moved between tanks deliberately and continuously. Boost pumps inside each tank push fuel toward the engines. Cross-feed valves allow either engine to draw fuel from any tank. Transfer pumps move fuel between tanks to manage distribution. Multiple pumps, multiple valves, multiple paths. Fuel is constantly moving inside the aircraft. This is the part most people never think about. Fuel is not just burned, it is used to balance the aircraft. As fuel is burned, the aircraft's weight changes. As fuel moves between tanks, the center of gravity shifts. Modern aircraft actively transfer fuel during cruise to optimize the center of gravity for fuel efficiency. On long-haul aircraft like the A380 or 777, fuel is moved between the wing tanks and the trim tank in the tail to keep the aircraft trimmed at the most efficient flight attitude. The fuel system is not just feeding the engines, it is balancing the aircraft. At the end of the journey, the fuel reaches the engines. It travels through fuel lines, through filters, through heat exchangers that warm the fuel to prevent ice formation at altitude, and finally into the engine fuel control unit. The fuel control unit meters the exact quantity required for the thrust setting selected by the crew. It manages the fuel flow during start, taxi, climb, cruise, and descent. It responds to thrust lever commands within milliseconds. Modern engines are FADEC controlled, full authority digital engine control. The pilot moves the thrust lever. The FADEC translates that into the precise fuel flow needed at that altitude, that temperature, that engine condition. The pilot does not control fuel flow directly, the system does. Now let me tell you what we look at on the ground. Every walk-around inspection includes the fuel system, tank vents, drain points, refuel panel, fuel leaks from any line, filter inspection at scheduled intervals. A fuel leak is not just a maintenance issue, it is a flight safety issue. A loss of fuel in flight changes the burn calculation, changes the weight, and in extreme cases changes the center of gravity. If the fuel system is wrong, the aircraft does not fly. When I sign off the fuel system, I am confirming every component is functioning, every tank is sealed, every measurement is accurate. That signature is the same as every other system signature. The aircraft does not move until that work is verified. A fuel system is not just storage and pipes. It is a continuous management process from the moment fuel enters the aircraft to the moment it is burned in the engine. Hundreds of sensors, multiple pumps, cross-feed redundancy, quantity measurement, temperature management, center of gravity optimization. Every component working together to deliver fuel to the engines safely, efficiently, and predictably. 200 tons of fuel not stored? Managed. Every second of the flight. I am an aircraft maintenance engineer. The fuel system is one of the most elegant pieces of engineering on a commercial aircraft. And now you know how it works. Not stored, managed. If you want to understand what is actually happening every time you fly, subscribe. I break it down in a way that actually makes sense. See you in the next one.